calculate the energy required to excite the hydrogen electron from n equals 1 to n equals 2. Once we have that energy, we can calculate its wavelength, or the wavelength of that energy. All right, so we are given this formula. On your formula sheet, we're giving you give you that equation, which is the same thing as saying delta E is equal to the energy of the electron in its final position minus the energy of the electron in its initial position. All right, because delta E is the change in energy of this electron transition. All right, and we know that energy is equal to negative 2.178 times 10 to the negative 18 joules, and then we can use this z squared over n squared, and so you do that for that and you can get that. All right, anyway, we're just going to use this, but I'm just giving you some options, whatever you prefer. All right, we're going to use that equation there. All right, so let's save a little time here. Z for hydrogen is 1. Z is the nuclear charge, or the atomic number, or the number of protons. So all of them mean the same thing here. It's just 1 squared is 1. So we can just ignore that. All right, now in the parentheses it says 1 over the final energy level squared. So where did it end up at? It ended up in energy level 2. We're going to square that. That's going to be 4, or 1 over 4, minus 1 over, where's the initial starting position of that electron is n equals 1. N squared is 1. 1 over 1 is still 1. All right, so this whole part is going to be 1/4 minus 1, which is going to be 3/4. So we're going to plug in 3/4, or rather negative 3/4 over there. All right, just let the calculator do the rest. All right, negative 2.178 times 10 to the negative 18 times, what would I say, 3/4, times 3 divided by 4. Oh, negative. All right, sorry. So times negative 3 divided by 4. So I'm just going to multiply this by a negative 1. So there it is. Energy required is 1. Lost it. No, 4 sig figs. So that's just what's in our equation. 1.634. 1.634 times 10 to the negative 18, did it say? Yeah. Joules. So there's our answer to the energy required to excite an electron in hydrogen from n equals 1 and n equals 2. Now let's calculate the wavelength of that energy, because it's talking about the same thing here. It's going from the ground state, which is n equals 1, to the excited state, which is referring to n equals 2. So it's the wavelength of that energy, of that light. Okay. So we have energy, and we're asked for wavelength. We have an equation for that. It's energy is equal to Planck's constant times the speed of light over wavelength. And then you know that that comes from energy is equal to Planck's constant times frequency, and frequency is speed of light over wavelength. Mash those two, and you get that. All right, let's get some of this paint off the screen and rearrange this to solve for wavelength. That'll save us a little time. All right, so we can cross multiply there, and we're going to get E energy times wavelength is equal to Planck's constant times the speed of light. We cross multiply when we have fractions, and we want to get rid of them. All right, we're going to isolate wavelength by dividing through by energy. Just your algebra going on here. And then you have wavelength is equal to Planck's constant times the speed of light over energy. Now we can plug and play. Planck's constant is 6.626 times 10 to the negative 34 joules times seconds. I don't know why I'm writing sideways. Just habit, I guess. 2.998 times 10 to the 8 meters per second. All right, we can see the seconds cancel out. So is the energy. What was that? 1.634. Times 10 to the negative 18 joules is what we calculated. Actually, I have a better calculated number for that in my calculator, so that's the one I'm going to use. I'm going to round only at the end. All right, joules cancels out. We are left with units of meters. That is the SI unit for length. Wavelength, this is. Let's punch these numbers in. All right. 6.626 times 10 to the negative 34 times the speed of light, 2.998 times 10 to the 8 divided by, I'm going to use this number that I got earlier because it has a little more precision than the one I rounded for my first part of the answer. All right, 1.216. Pick a darker color. 1.216 times 10 to the negative 7 meters. All right, and we know that is also the same thing as 121.6 nanometers.